Welcome back, guys. So in the previous lecture, we slightly touched LLVM IR structure, see how it's compiled, assembled, disassembled, etc. So let's quickly recall the previous lecture. We have the very simple LLVM IR program, right? Just the main function, which returns the value 42. And this is what is known as human readable IR. In order to compile it down to bitcode, we use assembler tool, which obtains the machine level bitcode. And there's inverse tool called LLVM disassembler. So in today's lecture, we'll start looking into LLVM module and see how we're going to compile this file. And pretty much we'll need three components. One is called module itself, right? That is the container of all the functions, global variables, constants, etc. There is a component which is called context, which we can think as a container of modules. And the third component, which is known as IR builder, that is the set of APIs which allows us generating the IR. Right, so if we take a look at the structure, inside the context we have modules, and each module contains different metadata, as we have seen previously, like data layout, target machine, etc., global variables, function definitions, function declarations, right? We will see later how they differ. And in order to emit specific IR data, we use the IR builder. So that's pretty much it. Three components which we'll need to start building our compiler. Okay, let me switch back to the implementation. Okay, so source directory, and as we agreed, we'll be using simple header files, that is eva llvm.h. Okay, so we present our compiler as a class, where the main API method is exec. In fact, we'll have the compile method as well, but from this perspective, it also looks like an execution engine. Okay, so here's what should happen inside our main API method. First of all, we need to parse the program, right, and obtain the AST. Then we have to compile that AST down to IR. And the last step, we need to save this IR down to external file. Right, let's call it out.ll. And following our diagram, as we said, we have three components. Right, the first, which is called context. And again, the context is just implementation detail, which we can think as a container of modules and other data. Now, the more important component is the module. And as we said, which contains global functions, variables, constant, etc. Notice we use unique pointers here, since we keep those in only one instance. And the final component, which allows us actually emit the code, is called IR builder. And in order to use the context module and builder, we need to include those header files, right, from the LLVM installation. Okay, sounds good. Now we need to initialize those components. So let's introduce the helper method, module init, right, inside which we create the context. We create the module, passing the context, and let's call our module as eva LLVM. And finally, we create the builder, also for the same context. And today we're going to generate just the empty module, no any instructions or objects. So let's implement actually the last helper function, save module to file. Okay, so we accept the file name as a string. And we can write details of this file using the file descriptor output stream from LLVM. Right, which accepts the file name, and we also need the error code. So let's allocate the error code. Okay, so once we have the output stream, we can pass it down to the print method of the module. And the second parameter might be null pointer here. This is for extra assembler annotations. We don't need it. Okay, sounds good. We now have module and can save this module to the file. Again, this module doesn't contain anything yet. We don't generate any code, but this should already save the name of the module. Actually, let's also print the contents of the module to the standard outputs. For this, instead of file descriptor, we can pass the LLVM output stream, and this will print the contents to the console. Okay, so that should be it. Let's create the main executable file. As we said, we'll have only one executable file, right? eva llvm.cpp, which is our main function. Right, let's include our compiler. Here's our program. Okay, then we create the compiler instance and call the exec method. Okay, so that should be it. Now remember, we used the header files from the LLVM infrastructure, and for this we need to specify for Clang extra path where those libraries are located. Now the way to use it is through the tool, which is called LLVM config. For example, if we pass the C++ flags, it shows what kind of flags it includes. In particular, as you can see, it says the standard for C++ is C++14, includes standard library, and also uses the include for the LLVM headers. And when compile our main executable, we can call the LLVM config tool, right, using those apostrophe symbols. We need to pass C++ flags, also linker flags, system libs, and core libraries. And we specify which file to compile, eva_llvm.cpp. Okay, let's try it. And it's compiled. Let's see. Right, we got the executable. Let's try executing. And there we go. We got our module. As you can see, eva_llvm. Again, it doesn't contain anything, but it's fully working module. Now, once we executed our compiler, it should generate the file out.ll. Let's see. And here it is, out.ll, and which should contain exactly the same module, right? The empty module with just source file name. And that's exactly correct. Okay, so that's it for today. We started building our compiler, got familiar with three components. Again, the context, the module, and the IR builder, and generated the first module. It's still empty, but this is our main output, which we'll fill in the next lectures. That's it for today. Thanks and see you in the class.